Okay, we are going to look at some specific types of numbers and classify them. Uh, Specifically, we're looking at rational numbers versus irrational numbers. So we'll look at some vocabulary first. Our first word is real number. So it's our first vocabulary word. A real number is any rational or irrational number. So this is all of the numbers you have encountered up to this point are considered real numbers. So every number that you have seen so far is a real number. You won't see anything other than that until high school. So far, every single number that you have seen and that you will see this year will be considered real numbers. The next word is one that you've seen before, but we're going to go ahead and look at it again. Irrational number. This is a number that cannot be written as the quotient of two integers. In other words, a number that cannot be written as a fraction. So far up to this point, every decimal that we have seen, we were able to convert into some sort of fraction. Okay, we've seen terminating decimals and repeating decimals. Both of those decimals can be turned into a fraction. What we have not seen yet is a decimal that never ends. So if we're looking at decimals, a decimal that never ends or repeats, because technically a repeating decimal never ends either. The only thing is, even though a repeating decimal doesn't end, we actually know the pattern. The pattern makes sense. A decimal that never ends is one that has no pattern, goes on forever. There's no rhyme or reason to the decimal. I always like to think of it like an irrational person is crazy. An irrational person is unpredictable. You don't have any idea what they're going to do next. And that's kind of like a number two. There's no rhyme or reason. There's no understanding it. There's no end to it. It doesn't have a pattern. Okay. An example of a decimal that never ends or repeats that you may actually already know would be pi. So pi is an example of an irrational number. The decimal has gone on forever. Like there has been no end to it, no pattern, no computers can find any end or pattern. So pi is definitely an irrational number. The other types of numbers that create decimals that never end are square roots of non-perfect squares. Okay, remember a perfect square is a number that has two factors that are the same. So 4 is a perfect square because 2 times 2 equals 4. 9 is a perfect square because 3 times 3 equals 9. So if you have a square root of a number and the number inside is not perfect, it's automatically irrational. Those are the two main things you'll see. Or if they give you a decimal, like 3.278, if you see these little dots at the end of the decimal and there's no repeating line, those 3 little dots tell you that this goes on forever, which means it's irrational. If there's no repeating bars, that means there's no end to it. Okay. Next word, Rational number. It's a number that can be written as the quotient of two integers. So a number that can be written as a fraction. Obviously, if you see a fraction, it's rational. But also remember, if we are given a fraction, we could convert that into a decimal. And the decimal will either end or repeat. So we can also add that we have decimals that end or repeat. Those are all considered rational numbers. So we have a number that is a fraction or can be written as a fraction, decimals that end or repeat. We also have the square root of a perfect square, which again, that means it's a number and we can find two factors that are the exact same number. So 16, 4 times 4. 64 is 8 times 8. They're actually the numbers that go diagonally through a multiplication chart. The next type of number we have here, now the rest of the vocabulary that you'll see are all types of numbers that can be considered rational. And we'll lay it out in a little bit too on your chart. So an integer is a number with no fractional part. Counting numbers and their opposites and 0. So where it says no fractional part, that means the denominator would be 1. Okay. If you have 1/2, that's a fractional part. So we're looking at counting numbers like 1, 2, 3, 4, and the opposites, and 0. So we could have -4, -3, -2, -1, 0, 1, 2, 3, 4, on forever and ever and ever. So our counting numbers like 1, 2, 3, 4, and the opposites, and 0. Those are all considered integers. And again, where it says no fractional part, that means that the denominator would just be 1. So it's kind of like whole numbers and the opposites. Now let's look at whole numbers. With integer, you can't really say whole numbers are integers. That's half of the numbers. Whole numbers make up half of our integers, but we also have the negative version. There's no such thing as a negative whole number. That's why I said counting numbers before. But in this case, we are now looking at actual whole numbers. So we start at 0 and we look at positives. Again, a whole number, if you were to write it as a fraction, would have a 1 in the denominator. So these numbers could be written as fractions, but we usually don't. So those are examples of whole numbers. Natural number. Natural number isn't some type of number you really hear about now that you're in middle school. But a natural number are positive integers, no 0. So we actually start at 1. So a natural number does not include 0. Okay, so we're going to fill in the graphic organizer. A lot of boxes here. The vocabulary words that we just looked at, we're going to place inside our rectangle here. Now, the first thing I want you guys to know, our first word that we covered was real number. Everything that's inside all of these rectangles, all of these numbers included, are real numbers. So everything inside is considered a real number. Now from there are two main types of numbers we're looking at: rational numbers and irrational. Now inside these boxes, we're not going to rewrite the definitions. We're going to look at some examples. So the first of the two vocab words that we looked at were irrational numbers. So one example were decimals that do not repeat and do not end. So 0.172 ... Nothing repeats and it goes on forever. Pi is another very famous irrational number. We also talked about square roots, where the number inside is not perfect. 2 is a pretty common one that you may see. Nothing times itself equals 2. So again, the number that's inside, there are no factors that is a number in itself. So maybe think of a couple more square roots where the number inside is not perfect, or decimals that never end. Now for rational numbers on our left side, we do have decimals that repeat or end. So 3.17, where there's a repeating bar, or 0.25. Oops. My pen's not writing. Hold on. Let's try that again. Uh-oh. Sorry guys, something's funny here. Okay, sorry about that. Technical difficulties. So 0.25, a fraction, so any number that can be written as a fraction. 2/5. Whole numbers, the number 7 would be a rational number. I could make it a fraction if I wanted to. The square root of a number that's perfect, like 16. 4 times 4 is 16. Okay, so these are all examples of rational numbers. Something else you might see is if you have a fraction where one of the numbers inside is rational, like square root of 4 over 5. Square root of 4 actually equals 2. 2/5 is a fraction. On a same note, if you had if we look under the irrational section, if I had a fraction like 5 over pi, yes, this is a fraction, but because the denominator is irrational, the whole thing is irrational. Same thing if I had square root of 7 over 3. It's a fraction, but one of the numbers is irrational. So because 7 is not perfect, that makes square root of 7 an irrational number. If you were to put square root of 7 in a calculator, you would end up with a decimal that never ends. Okay. Let's look at the next section. On the left-hand side, this next largest box, we have integers. So our next section is an integer. Integers are counting numbers, positives and negatives. Like 7, -8, 0, 2, -5. Our next box inside are whole numbers. Our whole numbers are not negatives. They're in the positive integers, including 0. So 0, 12, 110, 70. And finally, we have natural numbers. And that's a capital N, or excuse me, that's an N, not an H. Let me make that clear. Natural numbers are whole numbers except no 0. So it's anything that's not 0. Okay, so it's not 0. You don't have to write that, but okay. So what we want to look at here with this diagram is if a number is an integer, it falls under the rational number area, so it's technically a rational number. A whole number. Whole numbers fall within the rational number area, so all whole numbers are rational. So every number within this nesting little rectangle shape are all considered rational numbers. We're just now breaking them down into more specific groups. So everything on the left is considered rational. Everything on the right is considered irrational.